In this video, we'll evaluate some compound functions that have inverse trigonometric functions as part of them. Here's an example. Sine of tan inverse x. We need to evaluate this. Now pause the video, think about how we can approach this. Okay, so let's think about this. This is sine of an angle. This angle is tan inverse x. So what we need is sine of this angle. Let this angle be theta. So if this angle is theta, then what we need is sine of this angle, sine of theta. And what we know is this. We've assumed that tan inverse x is theta. This means tan theta is equal to x. Now imagine a right angle triangle. In this triangle, one angle is theta. What we know is tan of theta, that's equal to x. And what we need is sine of this angle, sine of theta. How can we approach this? Pause the video, try this out. Okay. So we can use this triangle. We can say that if tan theta is x, this is x and this is 1. If this is x and this is 1, by Pythagoras theorem, this hypotenuse is root of 1 plus x square. Now we have all three sides. We can figure out sine or cos or whatever we want. We need sine theta here, sine of this angle. So sine of theta is equal to the opposite by hypotenuse. That's equal to x by root of 1 plus x square. So using tan theta, we figured out sine theta. That's equal to x by root of 1 plus x square. This is what we needed. We needed sine of this angle, sine of theta. That's equal to x by root of 1 plus x square. Let's try one more problem. We have tan of half of this thing. This is sine inverse this plus cos inverse this. This is sine inverse of 2x by 1 plus x square. And this is cos inverse of 1 minus y square by 1 plus y square. Two different variables, x and y. We need tan of half of all of this. Now, how do we evaluate this? Pause the video, try this out. Okay, so if you look closely, you'll see the identities that are required. We have a sine inverse of something. How can we make this sine of an angle such that sine inverse and sine can talk to each other? Similarly, this is cos inverse of something. How can we make this cos of an angle so that cos inverse and cos can talk? So if we assume x as tan of theta, this becomes 2 tan theta by 1 plus tan square theta. That's actually sine of 2 theta. Similarly, if we assume this y as tan of phi, some other angle phi, this is 1 minus tan square phi by 1 plus tan square phi. So this becomes cos of 2 phi. So using these two substitutions, we will be able to cancel out sine inverse and cos inverse. Let's see how. This is sine inverse of 2x by 1 plus x square. That's equal to sine inverse of 2 tan theta by 1 plus tan square theta. That's equal to sine inverse of sine 2 theta. Now sine inverse and sine cancel out. This becomes 2 theta. Similarly, this is cos inverse of 1 minus y square by 1 plus y square. That's equal to cos inverse of 1 minus tan square phi by 1 plus tan square phi. This is an identity. This is cos of 2 phi. So this becomes cos inverse cos of 2 phi, which means it's equal to 2 phi. So this thing is equal to 2 theta and this is equal to 2 phi. Now we need to add them and then take their half and then find the tan of this. So half of their sum, 2 theta plus 2 phi, that's theta plus phi. So we need to find the tan of theta plus phi. That's another identity. Tan of a plus b is tan a plus tan b by 1 minus tan a tan b. So tan of theta plus phi is equal to tan of theta, that's x, plus tan of phi, that's y, divided by 1 minus tan theta tan phi, that's 1 minus x times y. So this expression is equal to x plus y by 1 minus xy. Let's solve one last problem. Tan inverse 2 cos 2 sine inverse half. So a lot is going on. We first find sine inverse of half, double it, then find cos of it, double it, and then find tan inverse of this. Pause the video, try this out. Okay, so let's start with the innermost angle, sine inverse of half. So let's assume that this angle is theta. This means sine of theta is equal to half. What do we need? We need to double it and then take the cos of twice of this angle, cos 2 theta. So which identity can we use? We can use cos 2 theta equals to 1 minus 2 sine square theta. We know sine theta, we can figure out cos 2 theta. That's equal to 1 minus twice of 1 by 4. That's 1 minus half, that's equal to half. So cos 2 theta is equal to half. Now what do we need to do? we need to find tan inverse of twice of cos 2 theta. So tan inverse of twice of cos 2 theta, which means tan inverse of twice of half, that's tan inverse of 1. Twice of half is 1. And what's tan inverse of 1? That's equal to pi by 4. So all of this, that's actually equal to pi by 4. And there's a slightly different way to do this. When we have sine theta equals to half, we can directly say that theta is equal to pi by 6. Sine of 30 degrees is half. Double of this, that's pi by 3, 60 degrees. And cos of 60, that's again equal to half. So we have cos of 60 here, that's half. Doubling it will give us 1. What we need is tan inverse of 1, that's equal to pi by 4.